Hello everyone, myself Twinkle Patel from Engineer Navsari. This video lecture is about Advanced Encryption Standard, that is AES. In this video lecture, we will discuss Introduction to AES, Encryption process in AES, which consists of SubByte Transformation, Shif rows, mix column, add round key. Then we will discuss the overall structure of the AES. After that, we will discuss key expansion in the AES. Then we will discuss avalanche effect in the AES. So first of all, AES stands for Advanced Encryption Standard. In the previous video, we have discussed that DES is a data encryption standard and which has a key size of 64 bit, which is considered as a small because of increasing computing power. It was considered vulnerable against an exhaustive key search attack. So a triple DES was designed to overcome this drawback of the DES, but it was found that DES is slow. So AES is designed which has a key size larger than the DES, and AES is also 6 times faster than the triple DES. So AES is designed to have the characteristics such as it is resistance against all the known attacks, its speed and code compactness on a wide range of platforms, and it is a simple in design. So first of all, we will see the general structure of the AES. The key size in AES is 128 bit or 16 byte or 4 words. Here consider the one word equal to 32 bits. So here key size is 4 words or 128 bit. Next, the block size is 128 bit 16 byte or 4 words. The subkey size is 32 bit 1 word or 4 bytes, but in each round 4 subkeys are used. So total key size is 128 bit 16 bytes or 4 words, and the number of rounds in the AES is 10. So total number of subkeys are used is 44 because each round requires 4 subkeys. So 10 each round require 4 subkeys, so 10 into 4, that is 40 subkeys are required, and pre-round calculation is also done here, in which also 4 subkeys are used. So number of subkeys are used is 44. Next we will see the general structure of the AES. First of all, 128-bit plaintext is given, and then pre-round transformation is applied. After that, round 1, round 2, in this way all the round calculation is performed and the ciphertext is generated. Here from the 128-bit key, the key is expanded to generate the key, that is generate the key for the all the rounds, and the key size is depend on the number of rounds. So if the key size is 128 bit, then the number of rounds in the AES will be 10, and if the key size is 192, the number of rounds are 12, and if the number of rounds are 14, then the key size is 256. So this is the relationship between the number of rounds and the cipher key size in the bits. So, according to the key size, the AES is also known as AES 128, AES 192, and AES 256. Now we will see the AES encryption process. So, first of all, plaintext is given to the pre-round calculation operation, that is add round key state, in which round key is applied. So 128-bit key is applied here. After that, subbyte state, shift row state, and mix column, and after that add round key is applied. So add round key, round 1 key is added to the given stage. So this is the round 1 of the AES, in which substitution byte, shift rows, mix column, and add round key operation is performed. After that, the output of this round is given to the next round, and all the round perform the same operation, that is substitution byte, shift row, mix column, and add round key. But here small change is here, that the round 10 doesn't contain the mix column operation to make the AES reversible, because here the AES encryption and decryption process are not identical. Here the decryption process is reverse of the encryption process, and to make the AES reversible, the mix column operation is not performed in the last round, that is in the round 10. After that, the ciphertext is generated. So this is a simple process of the encryption in the AES. First of all, add round key is applied. After that, in round 1, substitution byte, shift rows, mix column, add round key is applied, in which key 1 of the round 1 is applied. And in this way, all the rounds is performed. And in round 10, mix column, except the mix column, all the operations are performed using the key 10 of the round. Next, we will see how encryption process is done on the AES. So here 1 byte consists of the 8 bits. So 8 bit is converted into the column matrix. After that, this one word is equal to the 32 bit, that is of 16 byte. So here this is of 1 byte, this is another byte, and all the bytes are arranged in a column. Next is these all the we have a 128 bit of the plain text. So we have a 128 bit of plain text. So we have a total of 16 bytes. So all the 16 bytes are arranged in a block or a matrix, and the intermediate results are stored in the state matrix, that is S0, S1, S2 and S3. And also the intermediate result are also of 4 cross 4 byte matrix, that is result each cell of the intermediate matrix is consist of the 1 byte, and this one column of this intermediate state is considered as a one word, that is first column is considered as a W0, next column is considered as a W1, third column is considered as a W2, and fourth one is a W3, because each cell is of 1 byte. So total 4 bytes. 4 bytes equal to 32 bits, and 32 bits equal to 1 word. So all the operation is performed on the 4 cross 4 byte matrix. Next, we will see that the first n-1 round consists of the 4 distinct transformation functions. The first is substitution byte, in which the 16 input bytes are substituted using the S box of the AES. Next is shift row. Each of the 4 rows of the matrix is shifted to the left. Next is mix column. Each column of the 4 bytes is now transferred using the special mathematical function. And next is add round key, in which the 16 byte of the matrix are considered as a 128 bit, and which is XOR to the 128 bit of the round. So this is the main function or operation of the AES structure. We will see in all this operation we will see in detail. So first is substitution byte. So in substitution byte, AES S box is used. The size of AES S box is 16 cross 16. So in this, simple lookup table is used. So first of all, we have mentioned that the matrix, our input matrix is arranged in a 4 cross 4 byte. So to substitute the byte and rearrange them, consider the one cell which consists of the total 1 byte, that is 8 bits. So first 4 bits. So the leftmost 4 bit of the byte are used as a row number in the S box, and the rightmost 4 bit are used as a column number in the S box. Now row number and column number serve as a index into the S box to select the unique 8-bit output value. So in this way, all the input is converted into the intermediate output in using the S box. So this is one example of input and output of the SubByte transformation. Next is shift rows. In shift rows operation, the first row of the state is not altered. For the second row, a 1 byte circular left shift is performed. For the third row, 2 byte circular left shift is performed. For the fourth row, a 3 byte circular left shift is performed. So consider one example here. For the first row, state is not altered. So this is the input and this is the output. So for first row is same as the output of the first row is same as the input. For the second row, 1 byte circular left shift is performed. So 27 is left shifted. So BF, B4, 41, and after that 27. So this is the output of the second row. So 1 byte rotation is performed. After that, 2 byte circular shift is performed. So 5D, 52, 11 and 98. So 2 bytes are shifted here, and in the fourth row 3 bytes are shifted. So 30 after AE, F1 and E5. So this is the output of the last row. So in this way shift row operations is performed in the AES. Next we will see the mixed column operations. So in this, each byte of the column is mapped into the new value. That is a function of all 4 bytes in that column. Constant matrix is used by the mixed column, and the transformation is defined by the matrix multiplication on the state. So consider here example. This is our intermediate step after applying the shift rows operation. So here one matrix is used, and using this matrix multiplication is performed. So first of all, one column is multiplied with this matrix and the output is generated. After that second column is multiplied with this matrix and the output is generated for the second column, and third column is multiplied with this matrix and third column of the output is generated. After that fourth column is multiplied with this matrix and output of the fourth column is generated. So in this way each column is mapped into the new value, that is a function of all 4 bytes in that column. So the example is here. So this is our intermediate state output, and we are applying the mixed column operation here. So this is our output in which this matrix is multiplied with each column and output is generated for the each column of the matrix. Next we will see the add round key operation in the AES. In the forward add round key transformation, the 128 bit of the states are bitwise XOR with the 128 bit of the round key. So our key size is 32 bit, but total 4 keys are used. To 30 into 4, so total 128. Our round key is of 128 bit. So the 120 bit of the intermediate state is XOR with the 128 bit of the round key. So this is the XOR operation and the output of the XOR operation. So here operation is also performed column by column. First column is XOR with the first column of the round key and the output is generated. In this way all the columns are XOR with each other and the output is generated in add round key operation. Now we will see the overall structure of the AES. So overall structure means the encryption and decryption process both. So first of all, in encryption process, we are giving the plain text to the add round key, that is the pre-round calculation, in which 128 bit key is directly used. And after that round 1 is started, in which substitution byte, that is as box, then shift rows, mix column operations are performed, and after that add round key is performed. Here after the pre-round calculation the key is expanded and total 40 keys are generated from the one key, and this expanded key is given to the round 1. In this way all the round 1 to round 10 is performed, and the exception is the mixed column operation is not performed in the round 10 to make the AES reversible. So after that the ciphertext is generated. So here the encryption and decryption of process of the AES is not identical. So all the process which is performed in the encryption, the inverse of that process is performed in the decryption, and the key is also reversed. So this is the round 1 of the AES which apply the round 10 key of the encryption process. So in which inverse shift rows, inverse SubByte, add round key, inverse mix column operation is performed. In this way all the round perform the calculation in and the last round, as in the encryption mix column is not applied. So here also mix column operation is not applied in the round 10 decryption process of the AES. So this is the AES overall encryption and decryption process. Next we will see the AES key expansion. So we have a 128 bit key from which we have to generate the key for the pre-round calculation as well as all the 10 rounds. So for pre-round we require a total 4 words. one word equal to 32 bits, so 4 word equal to 128 bit key. Round 1 require W4 to W7, round 2 require W8 to W1, W11, so on. Or we have to generate word till W43. So total 44 key required for the AES key processing. So first of all, we have a key of 128 bit. 128 bit equal to 16 byte. So this 16 byte is arranged in a 4 cross 4 matrix as a key 0, K1, K2, K3, K4, K5. In this way, all the 16 byte of key is arranged. And this one column is considered as a, that is 4 bytes is considered as a one word. So that is W0, next column is W1, next is W2, next is W3. In this way, all the 4 word is generated. After that, each added word depends on the immediately preceding word. So apply the G function to the every fourth word, that is W3, W7, W11, etc. And then the output of the G function is XOR with the W0 and we have generated the W4. And after that, the W4 is XOR with the W1 and generated W5. As we have mentioned that each word is depend on the immediately preceding word. After that, the output of this W5 is XOR with the WT and generated W6, and W6 is XOR with the W3 and generated W7. And then the every fourth word. So here fourth word is W7. So W7 is applied, G function is applied to the W7 and the process will remain same and all the words are generated till W40. So in this way, key is expanded in the AES key expansion. Now we will see in detail the G function. So in the G function, first of all we convert a word into the, in G function we have applied a one word. So first of all we convert these 32 bits, that is one word, into a 4 bytes. So this word into the 4 bytes. After that we apply the circular left shift operation, that is V0 is circularly left shifted, so V1, V2, V3 and V0. Then apply the substitution byte operation using the S box, which is same as the S box of the AES encryption process. Then we apply the XOR operation with the round constant which is shown in this table. So if it is a round 1, then round constant is 0, 1. If it is round 2, then 0, 2 and so on. So we will apply the XOR operation with the round constant and the output of the G function is generated. Next we will see the example of AES and the avalanche effect in the AES. So this is the example of AES. So table shows the plain text, key and ciphertext. When we apply all the steps of the AES, we will get the ciphertext and as shown in the table. The avalanche effect states that a desirable property of any encryption algorithm that a small change in either the plain text or the key should produce a significant change in the ciphertext. So in AES, one bit change in the input will affect nearly all the bits of the output after all the rounds. So AES perform the avalanche effect. So this is all about the AES encryption and decryption process. As we have studied in the earlier lecture, DES follow the Feistel structure, whereas AES doesn't follow the Feistel structure, and the key size in the DES is 64 bit, whereas key size in the AES is 128 bit, 192 bit or 256 bits. The number of round in the DES is 16 and the number of round in AES is 10. And also the AES is more secure and faster than the DES. Thank you.